The law of sines, or deriving the law of sines formula. I have this triangle here, and I have some steps here that we're going to go through so you can kind of follow along and make sense of this. It's very important that you understand where this formula comes from. So the first thing I'm going to do is I'm going to find h, which is the height of this triangle, in terms of a, this side, and the sine of an angle. Now if I look at the triangle on the left, that this height divides this larger triangle into two smaller right triangles, we can call this triangle 1 and this one triangle 2. So if I look at triangle 1, then I can find h in terms of a and the sine of an angle by using angle b. So the sine of angle b is going to equal h over a, opposite over hypotenuse. Okay, this is the right angle, so the hypotenuse is a, h would be the opposite side for b. And then if I get h by itself, I'd multiply both sides of this by a, I would get a times the sine of b. Okay, now we're going to use that in just a little bit. The second thing I'll do is I'll find h in terms of a and the sine of an angle. So looking at triangle 2, so I'm going to find that in terms of b. So triangle number 2, I will use the sine of angle a. Okay, so the smaller right triangle, the opposite side would be h, and the hypotenuse would be b. So what I get then is, multiplying both sides of this by b, I get that the height equals b times the sine of a. Now, if you look at what we have here in these two expressions that we found, we have height equaling a sine b, or height equaling b sine a. And you can see that from, in this triangle, we found the same height in each of these cases, but we found it using two different expressions. So since they're both the same height, then these expressions that I've circled, a sine b and b sine a, have to equal each other. So a times the sine of b has to equal b times the sine of a. And those have to be equal because they're both finding the height of the same triangle. And what I'm going to do then is I'm going to divide both sides by AB. And you'll see what happens here in just a minute. On the left side, the A's divide out. On the right side, the B's will divide out. And so what I'm going to have then over here is the sine of B over B. And that has to equal over here the sine of A over A. Okay, so this is the first part, and we're going to use this in just a minute. Now, to continue this, we're still developing this formula. What you just saw is part of the formula. There's a little bit more that we have to find. Okay, so we're going to find K now in terms of C and the sine of an angle. Now this triangle is the exact same triangle as the one on the previous screen, but I've drawn the height in from a different vertex. On the previous screen it was drawn in from side C. On this screen now we're going to draw it from A. Okay, so K in terms of C and the sine of an angle. Again, we have two triangles. We'll call this one triangle 1, this one triangle 2. If I'm going to use side C, that's part of triangle 1. And it's going to be the hypotenuse of triangle 1 because here's the right angle. So the sine of B has to equal, with respect to B, the opposite side is K, and the hypotenuse is C. And so K, which is the height, is equal to C times the sine of B. Okay, again, that's multiplying both sides of this first line by C. And then in this next step, I'm going to find K again in terms of B and the sine of an angle. Well, if we look at side B, now it's part of triangle number 2. So I'm going to use the sine of C, and that has to equal K. With respect to C, K is the opposite side, B is the hypotenuse. So K over B, and then multiplying both sides by B, I get K has to equal B times the sine of C. All right, and the same thing here we're going to do again. I'm going to use algebra to show that these two are true, and it's going to be similar. This one equals K, and this one equals K, so they have to equal each other. So C sine B has to equal B sine C. And I'll divide both sides by BC, and I'll get the same thing in a similar pattern at least. The sine of B over B has to equal the sine of C over C. Now you remember from the previous screen that we ended up with, down here at the bottom, sine of B over B equals sine of A over A. So applying that here to this, sine of B over B equals sine C over C. On the previous screen, the sine of B over B equaled the sine of A over A. So all three of those things have to be equal to each other. So combining those together, I get this, which is the law of sines. So any two parts of this that you want to use at a time will give you something you can use to solve triangles for. Basically, the relationship is that the sine of an angle divided by the side across from it has to equal the sine of another angle divided by the side across from it. So A, B, and C really are irrelevant. It's knowing the relationship of this thing. Here, I'm going to find the length of side B. So that's what I'm looking for. In this case, I'm going to use the law of sines. I can't use sine, cosine, tangent alone because this isn't a right triangle. All right, now notice I have an angle here, angle A, and I have the side across from it, and I have angle B, and the side across from it is what I'm looking for. So out of those four things, two angles and two sides, I need to have one of them missing, and I have to have the other three. In this case, I have side, angle, angle, and remember that's one of the congruent shortcuts. All right, so the sine of A over A has to equal the sine of B over B. So that would mean that the sine of 59 degrees over 350 has to equal the sine of 38 degrees over B. And so now you can see that I'm solving for this missing piece right here, and this is a proportion. So we can solve it by cross multiplying. So multiplying this way, I get B times the sine of 59 degrees, and then multiplying this way, I get 350 times the sine of 38 degrees. Now using a calculator, I'll figure out the right side. So B times the sine of 59 has to equal 215.48. And then I will divide both sides by the sine of 59 to get B by itself. So B then equals 251.4. Okay, so again, law of sines, the sine of an angle divided by the side across from it equals the sine of another angle divided by